Hey guys, this is the lesson for finding greatest common factor of two whole numbers. So we're going to be looking at factors that multiply between two numbers that are less than or equal to 100. And then next, we'll be looking at least common multiple in our next session. So we're going to go ahead and just start with number one here. It says Akio has 27 blankets and 18 flashlights to use in emergency relief kits for communities in need. He will put the same number of blankets and the same number of flashlights in each kit. He wants to use all the blankets and flashlights. What is the greatest number of emergency kit relief kits Akio can make? So really what we're doing here is we're looking to see what is the greatest number that they can share to make a product. So I'm going to start by making factor trees on these. Okay, so I have 27 and I have 18. I'm always going to start by looking at what it can be multiplied by 1. Okay. Then I start trying to go down my list here, and having a multiplication table would be helpful to quickly recall those facts. So I did share a link with you guys to help you see your factors a little bit faster. So I know that 2 cannot be made to make 27, but I do know that 3 times 9 will make 27. If I make one of these factors, I don't have to put 9 times 3 because they are commutative and they're the same. Okay, so I'm going to go ahead and look over here. I have 2 times 9 and 3 times 6. Okay, so that's really where I'm leaving off there. Now what I'm going to do here is I'm going to look between my factor trees here. I see that they both share 9, or sorry, they both share 1, but that's not the greatest number that they share. They both share 3, but again, that's not the largest number that they have in common. Finally, I see they have 9. That's the largest that they both have in common because they don't share 18 or 27 and they don't share 6. So I'm going to go ahead and say that 9 is my greatest common factor. So Akio can make 9 emergency relief kits. So our GCF is 9. Okay, so we can make a list of them or we can do trees. I will be teaching you prime factorization for least common multiple, but I find that factor trees are more commonly used for greatest common factor, and they're a little bit more straightforward. Okay, so we're going to look at our next one, and it says find the greatest common factor of 56 and 96. So again, we're going to be looking at our factors. I like to start always by making our trees. Okay, so I'm going to go ahead and do 1 starting off. So 1 and 56, 1 and 96. Okay. And then, excuse me. And then I'm going to look and see, well, what else do I know off the top of my head? Do I think that 2 can be made here? 2 and 28 I know can go in. I can do 4 and 14. I can do 7 and 8. Okay, so I'm going to stop going through with that tree, and I'm going to move over here to 96. So I know that 1 and 96. I know that 2 and 48 will be okay. That will work. 3 and 32. And then I can do 4 and 16. Okay. And then I can also do 8 and 12. Okay. So when I'm looking through at this, I'm like, okay, I can see some clear as day that they have in common. 1, they have 2. They don't share 3, but they do share 4. They don't share 7, but they do share 8. They don't have a 12 or a 14. They don't have a 28, 56, 32, or 96. So the largest one that they do have in common, I can see, is 8. So in this case, our greatest common factor is 8. Looking at number 3, Reth says that the greatest common factor of 36 and 60 is 6. We'll see if Reth is correct. So we're going to go ahead and start with 36 and 60 up here with our factor trees. And I like to start with 1 And I'm going to go ahead and do 60 because 60 is a little bit easier for me to recall my facts. So I have 2 and 30. Okay, then I have 3 and 20. And then I have 6 and 10 and 5 and 12. Okay. Now I'm going to go over to my 36. I have, oh, sorry, I was just yawning. 2 and 18. I have 3 and 12. I have 4 and 9, 6 and 6. Okay, and I've listed quite a bit of factors here, so I'm going to go through and check and make sure what they share. I see a 1, a 2, a 3. They don't share 4. They do share 6, but that's not the largest number I see. They don't share 20, 30, and I'm really just scanning through, and I see that the largest one that they both share is 12. Okay, so in this one, our greatest common factor is 12. Oops, I thought that was the right marker here. So our greatest common factor here is 12. So Reth said that 6 is the greatest number. No, it's not the greatest common factor because I can see that if I can have 6 as a factor, I can also have 12 because that's 6 doubled here, right? So yes, 6 is a common factor, but it's not the greatest common factor. And then finally, looking at our last one here, Luis buys 16 bellflowers and 20 roses. He wants to plant an equal number of bellflowers and an equal number of roses in each of his flower boxes. What is the greatest number of flower boxes Luis can plant using all the bellflowers and roses? Show your work. So here we're just going to start again making our factor trees. Okay, I know that 16 is 1 and 16, 2 and 8. 3 cannot be used, so I'm going to just go ahead with 4 and 4. Okay, and then I'm going to move over to 20, which is 1 and 20, 2 and 10, 5 and 4, and then we'll stop there. I'm going to look through my list here. They share 1s and 2s. They don't have 8 or 16 in common, but they do share 4, and that's our largest number that they share. So we can go ahead and say that our greatest common factor in this case is 4. Okay. So while this does seem pretty simple, we're just listing factors and finding ones that they have in common. What we will do is we'll extend this in 7th grade math, where we're looking for factor when we're factoring out algebraic expressions. So this does come in handy. We want to be able to ask for these factors really quickly, recall them really quickly, and find ones that they have in common fast. And that'll help us with factoring algebraic expressions when they get into 7th grade math. So if you have any questions, please let me know and I would be happy to help you out.